clastic sedimentary rocks. So clastic sedimentary rocks are formed from the abundant deposits of loose sediments that accumulate on Earth's surface. These are the most common types of sedimentary rocks. Clastic comes from the Greek word klastos, which means broken. So it's broken bits of rock that are glued back together to make sedimentary rocks. These are further classified according to the size of their particles. And we have a chart over here that shows particle sizes. So if you start with the smallest particles, you got clay down here, which is less than 0.004 millimeters. You got silt, which ranges from 0.004 millimeters to 0.06 millimeters. So these are kind of on the microscopic scale, especially the clay. Then you got fine sand, medium sand, and coarse sand, which range from about 0.06 millimeters all the way up to 2 millimeters. Anything bigger than 2 millimeters is considered gravel. And you can have granules, you can have pebbles. Actually, you can go bigger than pebbles and have boulders as well. But these are our grain sizes. And these are all really just divided up by, you could use a sieve that has holes in it that are these size ranges, and you could actually divide a sample up into its different size grains and use that to analyze it. So coarse-grained rocks, these are conglomerates. So this is one type of coarse-grained rock, is a conglomerate. These are sedimentary rocks consisting of gravel-sized rock and mineral fragments. And then conglomerates have rounded gravel-sized particles in them. Now, due to its mass, gravel is transported mainly by high-energy flows of water, such as mountain streams, flooding rivers, some ocean waves, and then glacial meltwater. Now, gravels become abraded and rounded during transport as particles scrape against each other and on other rocks. And usually the further it travels, the more rounded it becomes. Okay, so this is a conglomerate. You have these sort of rounded off gravel-sized pieces in here that are kind of glued together. Kind of looks like concrete, really. So those are conglomerates. You compare that to breccia. This is another coarse-grained rock. But breccia is composed of angular gravel-sized particles. So the big thing here is these are more angular-sized pieces. Really, that's the difference between a conglomerate and a breccia. The breccia has these angular particles in it. The particles are angular because they did not have time or travel that far to become rounded. So these basically form pretty close to where they were weathered off the original parent material. And the particles were deposited close to where they originated. So these did not travel very far, so they were not rounded very much. Medium-grained rocks. So sedimentary rocks that contain sand-sized grains are medium-grained rocks. So sand-sized sediments are abundant in stream and river channels, on beaches, and in deserts. Sandstone has features that are of interest to scientists. Ripple marks and cross-bedding allow mapping of ancient waterways. But sandstone has a high porosity, which allows it to act as a reservoir rock for groundwater, oil, and natural gas. And then porosity. Porosity is the percentage of open space between grains in a rock. So we have high porosity here, you have low porosity here. So it's basically the amount of open space between these grains. So loose sand can have a porosity of 40%, some of which is maintained during the formation of sandstone. So it starts off with a 40% porosity. Some of that gets filled in with minerals that glue it together to make the sandstone during the lithification process and cementation process. But some of that pore space is left. So then sandstone can have a porosity of 30% still. So you lose some of this, but not all of it. If pore spaces are connected, fluids can travel through the rock. This makes sandstone layers valuable as underground reservoirs for groundwater, oil, and natural gas. If you have a water well, for example, usually you have drilled a hole into sandstone that has these pore spaces connected so the water can travel through it. And you have basically a little hole in the ground where you've drilled in, you put a pump down there, and that will fill in with water. So your water table's here. And then basically that little hole will fill in, you pump water out of that hole, and that's where your well water comes from. This draws down a little bit, and then the water from the surrounding rock kind of migrates back into this hole again. You pump it out again. So that's how you sort of maintain your well water. Fine-grained rocks. So sedimentary rocks consisting of silt and clay-sized particles are called fine-grained rocks. Examples include siltstone and shale. These rocks represent environments like swamps, ponds, and deep oceans with still or slow-moving waters. So the particles are allowed to settle. So fine sediments settle in very thin layers. Often these have low porosity, forming barriers that prevent the flow of groundwater, natural gas, and oil. They have low porosity because the particles that make them up, the silt and clay-sized particles, are very small and they can compact together very tightly. So there's not any pore space left in there.